broadcast of a television picture begins with a television camera. Inside most cameras, a prism system breaks light from a scene into the three primary colors of light: red, green, and blue. The colored light falls on image sensors called charge-coupled devices, or CCDs. When light falls on the CCD, it produces a pattern of electric charges. The CCD releases these charges line by line, producing an electric current called a video signal. The separate video signals are combined by an encoder into a single signal, which goes to a transmitter along with any sound or audio. The transmitter produces a television signal from the audio and video signals. This TV signal is broadcast by an antenna as an electromagnetic wave of an assigned frequency range or channel for that station. A television antenna picks up all broadcast signals that reach it. These signals produce electric current within the antenna. Inside the TV, the tuner selects the desired broadcast signal. Other parts of the receiver separate the audio signal and send it to a speaker system. The video signal is divided into three signals: one for red, one for blue, and one for green. The inside of the TV screen is coated with stripes or dots of red, green, and blue materials called phosphors. An electron gun for each color shoots an electron beam onto the screen, line by line, which causes the phosphors to glow. The beam's strength, which is controlled by the video signal, determines how brightly the phosphors glow. The patterns of light given off by the phosphors duplicate the image recorded by the camera, and the viewer sees a picture of the original scene.
Today I will introduce digital TV broadcasting for you. First, I will talk about digitalization of TV signals. This includes sampling, quantization, encoding, and we can also call it PCM coding. For video signals, the process of obtaining the image signals can be regarded as the sampling result of the color moving image in the vertical direction of the time domain and spatial domain. For example, we collect 25 frames per second, which means sampling in the time axis, and each frame is divided into 625 rows, means sampling in the vertical direction of y-axis. Therefore, the sampling of TV signals is actually done in the horizontal direction of x-axis. The original form of image signals is RGB signals. We should convert them to a luminance signal Y and two color difference signals R-Y and B-Y through coding matrix, and then convert them to YCRCB signals using completion coefficients KR and KB. Remember the midterm exam questions which ask us to convert the RGB to YUV? It is the same theory. We have several different sampling formats for video signals, including 42424, 42222, and 42220. The position of sample points in different formats are like. Then we talk about digitalization of audio signals. It also obeys the Nyquist sampling theory. Each frame is 64 bits. Forward 32 bits is left channel. Another 32 bits is right channel. We call front 4 bits in each channel precode, and call another 28 bits channel code. After digitalization, all signals will output to the next device through specific interface. After digitalization, I will talk about data completion coding of TV signals. We also call source coding. The signals after digitalization require large storage and highly demanding channel bandwidth. So we should use compression coding to eliminate the useless information to data reconstruction, which we call redundancy. For video signals, we have data redundancy and visual redundancy. The compression coding of video signals can be divided into predictive coding, which based on motion estimation and motion compensation. The second one is entropy coding. The third one is transform coding. In general TV broadcasting system, we usually use all three kinds of coding, what we call mixed coding, and it is widely used in MPEG-1, MPEG-2, and H.264. The redundancy in audio signals, including inaudible sounds, reach below 20 Hz and extend 20,000 Hz. Another is temporal redundancy and frequency redundancy. For audio signals encoding system, people usually use perceptual coding. Its structural diagram is like the contents with wavy lines are already taught by Dr. Hui in class. You can review them if you forget that. But I think Dr. Hui would be angry if you do so.
Then I will talk about data compression standards of compression coding, including GPEG, MPG1, MPG2, H.264, and so on. MPG2 is the most widely used standard for video signal, so we will focus on it. MPG2 defines 4 input image formats. We name it level, and 5 different processing methods. We call it profile. It includes video sequence, group of picture, lines, microblock, and block. MPEG2 use IBP compression coding method. H.264 become more and more popular. Audio compression includes MPG1 and MPG2.
Then let's talk about channel coding. It aims to improve the anti-interference ability of the transmission system. Channel model could be divided into random channel, burst channel, and mixed channel. Channel coding is also called error control coding. Its operating modes include ARQ, automatic repeat request, FEC, forward error correction, and HEC, We can classify the code according to its different application, which includes random error correction codes and burst error correction codes. All codes are based on Shannon theory, which is used to calculate the maximum transmission rate of the channel. We name it channel capacity. In 1949, Hamming code was promoted, but it can just correct a single bit error. Then cyclic redundancy check code was invented. Its cyclic shift characteristic greatly simplified the structure of encoding and decoding. These two codes can be classified as block code, which will operate after receiving the entire code word and need precise frame synchronization. Convolution code was promoted in 1955, which made full use of the correlation of information blocks before and after, and reduced the delay of decoding. Block code and convolution code belong to random error correction code. On the other hand, cross-product code is widely used to correct the burst error. In 1993, two unknown engineers promoted turbo code, which can make channel coding efficiency close to Shannon limit. Almost everyone is suspicious and disdainful about the fact that they leave mathematicians behind, but actually they did it. The decoder of the turbo codes has two component decoders, and the code is iteratively decoded between the two decoders, so the entire decoding process is similar to turbo operation. So this is why we call turbo code. It is widely used in 3G and 4G mobile network. But turbo code still has time delay to some extent, so people invent LDPC code, which has extreme high speed and low delay, and this code is closest to Shannon limit. After channel coding, let's talk about digital baseband transmission and digital modulation. The digital signal after source coding and channel coding is binary digital information. Its spectrum will start with low frequency and reach high frequency. We name it digital baseband signal. In short distance transmission, we can use baseband transmission system to transmit signal directly. The structural diagram is like: the code types include binary, ternary, and multivariate code. In long-distance transmission, we should use suitable modulation scheme to modulate the baseband signal in high-frequency carrier for transmission. The modulation signal is also called keying signal. We have different keying schemes: ASK, amplitude shift keying, FSK, frequency shift keying, and PSK, phase shift keying. ASK use different amplitudes to denote 0 and 1. FSK use different frequency to denote 0 and 1. PSK use 0 and 1 to determine the before and after phase of signal. Apart from these schemes, we also use QPSK, QAM, MQAM, MVSB, COFDM, and so on. Now I will talk about the digital TV broadcasting system, which includes cable TV broadcasting system, satellite TV broadcasting system, and terrestrial TV broadcasting system. We differentiate them according to the channel coding and high-frequency modulation schemes. Cable system use DVB-C technical standard. It use RS code, cross-port code, and convolution code as channel code, and quadrature amplitude modulation would be used as signal modulation scheme. Satellite system use DVB-S standard. It use RS code, cross-port code, convolution code, and quadrature phase shift keying modulation. In Europe, DVB-S2 is promoted, which use BCH code, LDPC code, cross-port code, and multiple phase shift keying modulation. Terrestrial system is the most widely used one. It has different international technical standards. Europe use DVB-T, which use RS code, outer cross-port code, convolution code, inner cross-protocol and COFDM maturation. ATSC is adopted in America, which use IS code, cross-protocol, and Chinese code modulation. In China, DTTB is promoted. It uses BCH code, LDPC code, and multiple quadrature amplitude modulation.
We are Evil Genius Team.
It's the motherfucking double G.